Hello everyone, how to solve this problem for the values of x if we have 3 to the power of x minus 2 to the power of x is equals to 65, and we solve this problem for all the values of x. So here you remember one thing is that our x should must be belongs to integers. Okay, so we solve this problem for the integral values of x. So here the very first thing we are going to do is first we need to rewrite this equation as this is 3 to the power of x. Here we multiply and divide the exponent of this both of these two terms by 2, and it will be written as 3 to the power of x and its whole exponent is 2 by 2 minus, in this case again we multiply and divide the exponent of this term by 2, and it will be written as in this form, and this whole equation is equals to 65. And further here in the next step we need to move 1 over 2 inside the term, and it will be written as 3 to the power of x over 2 and its whole square minus, in this case we have 2 to the power of x over 2 and its whole square is equals to 65. And now here we need to convert this exponential equation into the polynomial or into the quadratic of two variables form, so that here we just take the base of this term is equals to a. We will take the a is equals to 3 to the power of x over 2, and from here we take b is equals to 2 to the power of x over 2. Okay, so when we take these two substitutions, our above exponential equation will becomes in this form. So when you put it here, it will becomes a square minus, when you put this value here, it will becomes b square equals to 65. And further here in the next step we need to focus into the left hand side, and you see here this is the very famous formula, and it is equals to a square minus b square becomes a minus b times of a plus b. And in the right hand side we have this is 65. So here you see that in the left hand side we have these are the two factors are multiplied by each other, but in the right hand side we have only one factor, that is 65. So here we need to find the integers whose product will becomes here 65. Okay, so here we have the integers are, this is 13 times of 5 is equals to 65, and also 5 times of 13 is equals to 65, and 1 times of 65 equals to 65, and 65 times of 1 equals to 65. So here we have these are the four possibilities in which we get the product of two positive integers becomes here 65. So here we just solve this problem for positive integer values. Okay, so here we have these are the four possibilities, and now here if we make the relation between these two factors, and you see that a minus b is always less than or equals to a plus b. Okay, so here we need to choose those factors in which the first factor is less than the second factor. Okay, so here we have this is 13, and we know that 13 is greater than 5. So we reject this case because we need a first factor is less than second factor. So here 5 is less than 13, so we choose this factor, and here 1 is less than 65, we also choose this factor, and here 65 is greater than 1, so we rejected this case. Okay, so here we have these are the two possibilities. So here we convert our given question into these two cases. So here in this side we will be write our first case, and in the first case we compare these two factors with 5 and 13, and we get here a minus b is equals to 5 and a plus b is equals to 13. So this is our first case, and here we write our second case, and in the second case we compare these two values with these two factors, and we get here a minus b is equals to 1 and a plus b is equals to 65. So here you remember that our target is to get the values of x only. Okay, here we need to find the values of x. So here first we need to focus on first case, and here we call this is equation number 1 and this is our equation number 2, and here So here when we add equation number 1 and equation number 2, it will be written as, so this minus b and plus b are cancelled out by each other, and we get here a plus a becomes 2a equals to 5 plus 13 becomes here 18. Okay. So here when we move this 2 to the right hand side, or in other words we divide both of the sides by 2, because here we find the value of a first. So these 2 and 2 are gone, and we get here the value of a is equals to 2 9s are 18. So here we easily get the value of a is equals to 9. So here our target is to find the values of x, so that here we move backward and we put this value of a here. So the value of a is 3 to the power of x over 2 is equals to, this is 9, and we write this 9 as 3 square. So here you see that the bases on both of the sides are same. So we equate its exponents, and after equating its exponent we get here x over 2 is equals to 2, and here we move this 2 to the right hand side and we get the value of x is equals to 4. So this is the first root of the given equation which we get here from first case. And now here for the second root we need to solve the second case, and in this case we call this is equation number 3 and this is equation number 4. So here we again add equation number 3 and equation number 4. So here this is negative and positive term are cancelled out by each other, and a plus a becomes 2a, and 1 plus 65 becomes 66. So from here we get the value of a is equals to 33 after dividing by 2. Okay. So here when we back substitute the value of a, so the value of a is 3 to the power of x over 2 equals to 33. So this cannot be gives us the integer value. Okay, it will be gives us the real root, so that we rejected this case because it cannot gives us the integer solution. And now here we again subtract equation number 3 and equation number 4. So when we subtract these two equations, it will be written as, so after subtraction we need to change the sign. So here a are cancelled out by each other, and minus b and minus b becomes minus 2b, and 1 minus 65 becomes minus 64. So here we need to again divide both of the sides by minus 2. So this minus 2 and this minus 2 are cancelled out by each other, and we get the value of b is equals to, this and this are gone, and 2 3s are 6 and 2 2s are 4. So here we easily get the value of b is equals to 32. So we again move backward and we back substitute the value of b. It is 2 to the power of x over 2. So when you put this value here, it will becomes 2 to the power of x over 2 equals to, we write this 32 as 2 to the power of 5. So again you see that bases on both of the sides are same, so we equate its exponents and we get x over 2 is equals to 5, and this implies that x is equals to 10. So this is the second value of x. So here we get the solution set of the given question is 4 and 10. So these are the two solutions of the given equation, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.